A uniform rope of length 12 meter and mass 6 kg hangs vertically from a rigid support. A block of mass 2 kg is attached to the free end of the rope. A transverse pulse of wavelength 0.06 meter is produced in the lower end of the rope. What is the wavelength of the pulse when it reaches the top of the rope? This is a question from the chapter Waves. Okay. Now, as per the question, a transverse pulse of wavelength 0.06 meter is given at the lower end of the rope. Now, they have clearly stated that the mass of the rope is 6 kg and it is having a length of 12 meter. Okay. Now, a 2 kg mass is hung from it. Now, we are supposed to find out what is the wavelength of the pulse at the top of the rope. That is the portion from point from which it is hung. Okay. Now, we know that velocity is equal to root of T by mu, where T is the tension, mu is the mass per unit length. Okay. Now, the tension at the lower end of the rope depends on the masses hanging below it, right? The 2 kg mass is actually causing a tension in the lower end of the rope, which we can call it as A. So the tension at the lower end A is due to the mass 2 kg hanging there, and that tension will be equal to the weight of the block, which can be written as 2 into G. Okay. Now, similarly, the tension at the point B, the point where the rope is hung, is actually due to the mass of the rope and the mass of the 2 kg block. Therefore, what will be the total mass? The mass of the rope is 6 kg and the mass of the block is 2 kg. So the tension at the point B will be, due to both the masses, it will be equal to 8G. Okay. Now from this equation, we actually know one more relation connecting velocity and wavelength, right? What is that? V is equal to mu lambda. V is equal to mu lambda. So from here we can write root T divided by lambda is equal to root mu into the frequency mu value. Okay. So from this, it's very clear that mu value is not going to change and the frequency is also not going to change, which means we can write this root T by lambda is the corresponding constant there, or we can write first case root T1 by lambda 1 at the bottom. So at the bottom it is actually point A, so TA, wavelength I'll call it as lambda A. This will be equal to root of TB by lambda B. Okay, substituting the values, but again TA is 8G, so TA is 2G, so root 2G by lambda A, lambda is 0.06, right? This is equal to root 8G divided by lambda B. Fine. So root 8G, right? So G and G cancels out. 8 is actually equal to 2 root 2. Root 2 and root 2 gets cancels out. So 2 is remaining. And lambda B, you'll be getting it as 0.12 meter, which is the wavelength of the pulse when it reaches the top end of the rope. Okay. I hope it is clear. Right. Thank you.